Hi everyone, we're going to graph y equals log base 2 of x and do this information on the graphs. Before you can graph it though, you have to know how you first have to do a table of values for y equals 2 to the x because that's the inverse. So basically this is your function, this is your inverse, and what I did is I did my table of values first for y equals 2 to the x. Then I switch the x and y's here for the function I want, which is y equals log base 2 of x. So, and then we're going to answer this information, and it's just the same as we did before with our natural log. So let's graph it. It's going to look like this. And then we have 2. What do we have? We have 2 goes to 1. All right, so basically this is what it looks like. All these logs basically look the same. All right, there it is. The domain is x is greater than 0. That means we have a vertical asymptote at x equals 0. And our range is y is all real numbers. Okay, it does have a x-intercept or a root at 1, 0. And then what else do we have to do? All right, where is it positive? We kind of already talked about it. Y is positive we're looking at the x values. So it's positive from 1 to infinity, and y is negative in this quadrant 4 area from 0 to 1. All right, as you talk about in behavior, which is here and here, what we're going to say is as my y gets bigger and bigger, so does my x. And as y goes to the left, or goes negative down to the negative infinity here, so it's negative infinity. As y goes to negative infinity, x approaches 0. All right? Now, what else do we need? This is 1 to 1, so we can have a inverse without having to restrict the domain. There is no symmetry, so the function is neither even nor odd. And then we have, so let's just do the inverse. The inverse, like I said on this one, is just y equals 2 to the x. So if I graph my original, so we have this going on. If I graph my original and I switch the x and the y's, we'll get this. There's your y equals 2 to the x. And we already graphed this on a previous video. So it's reflective over the y equals x. All right? So this is your inverse. And this is your original. Okay? And then we have to do transformation forms. So we have y equals log base 2 of x minus h plus k. So I'm going to draw my original again. So it's something like this. And if I want to shift this, let's shift it to the right by 4. So this is going to be log base 2 of x minus 4. And all I'm going to do is move these points over by 4. That means I have my vertical asymptote for my original was x equals 0. So now I'm going to move it over at 4. 1, 2, 3, 4. And draw a new vertical asymptote at x equals 4. And then just plot my points, move everything over by 1. And so there it would be something like this. I just shifted everything over by 4. That means my domain changed as well. X is greater than 4. Now let's shift up here. And let's just put plus 4. Whoops. Let's put the X. So X plus 4. So on these logs, remember that you have to use parentheses to signify the horizontal shift. So if we go up 4, I'm just going to take this and move everything up by 4. 4. And I'm just moving everything up by 4. And you get kind of a general idea of the graph. In this case, the domain stayed the same because we didn't shift it left and right, because your domain is your horizontal shift left and right. And that's all of this one. The next one we're going to do is very similar, but it's log with the base of 1/2. Thank you and have a nice day. Bye-bye.